the thrust of today's talk is to give you an introduction to a technique to make managing the feature flags in your code base easier. I'm going to give a brief reminder of what a feature flag is. I think many of you know since you're using them, but still we'll spend a little time talking about what a feature flag is. Talk about some of the pain points you may have encountered when doing this. I'd love it if, as we go along, if you're running into these pain points, if you comment in the chat. Then work through sort of the evolution of the technique. I want to talk about sort of where we started and where we ended, and then talk about this in some details. As I mentioned earlier, I am a front-end developer here, and this talk is rooted in React and Redux, that particular technology stack. However, the technique here is actually applicable to front-end, back-end, Java, JavaScript, Kotlin. It's really applicable to anything. All the examples here are in JavaScript, however, so if you aren't a JavaScript person, bear with us. You certainly can transplant this to your preferred framework easily. No technique, nothing like this is from one person's mind, so I just want to briefly mention that the front-end team here at Split all contribute to help evolving this. So to get started, let's talk a little bit about feature flags. So a feature flag is at the most basic, a conditional check you put in your code. If the feature flag is turned on, show one version of a feature or one feature, and if it's off, don't. One of the values of this is it begins to separate the notion of deploy from release. So if you're using feature flags, you can be adding new code to your code base, deploying it to, through your staging environment, your test environment, your prod environment, with the assurance that no one's going to be able to see the work in progress. It allows you to increase your developer velocity by getting code out into production quickly. Once you have your code deployed, then you can release it. So this is now, with feature flags, is a separate process. The release process is usually controlled by someone like a PM or something like that. So the feature is being developed, it gets deployed to prod, and then a PM can use some remote console to decide when to turn the feature on or off. So once the development is done, it can be turned on for the customers. At its simplest, you're going to just deploy the code, it's going to get done, the PM will just turn it on and everyone will use it. But the real value of a feature flag is allowing more fine-grained control over the release. So with whatever console you're using, you can control who can see it. At its simplest, you're going to lose your train of thought. At its simplest, you're going to turn it on for like 1% of your users or 5% and then increment from there. But it will be really interesting. You can do other things instead. You can, for example, say, I want to turn this on for Europe and not North America. You can say, I want to turn this on for our customers who want to be living on the bleeding edge, but not for the people who are like resistant to change. So you can have a lot of control over who gets to see the new feature and how they get to see it. This all by itself is good. The improved development process of deploying and increased control over release are great, but the real value for a feature flag comes in with measurement. So once you've started releasing it, let's say you show it to 1% of your users, being able to measure and say, oh, we're getting more 500s. Well, is that some coincidental anomaly, or is that because of this feature? Being able to correlate the, for example, increased number of 500s that you're getting from your HTTP calls with who's using the feature flag allows you to say, oh, this feature flag, this new feature is causing these problems. Maybe we should roll it back. Or, gosh, this has nothing to do with a new feature. There's no correlation. That gives you sort of engineering level metrics and engineering level confidence around your releases. But you can also then layer in business metrics and say, oh, well, this new feature appears to be giving us, more people are buying things, more people are staying on the site longer, we're getting more of what we want out of this product to start with. Or conversely, you can be doing business measurements and say, no one's actually using this feature, let's not invest more in it. And so you can use it to optimize your company's feature delivery and help to use data to decide where to be investing your company's resources. So that's the basics of a feature flag. It is really allowing you to optimize your business processes and be efficiently delivering and making decisions for your business rather than just sort of guesswork or luck. So moving on, commonly you're going to use a feature flag kind of like this. You're going to have some SDK. You're going to call that SDK, say, here's my flag for this user. Tell me whether this user can see the new feature or not. That'll in some way consult some set of information and decide this user can or cannot see the new feature. And if so, then you show that if they can see it, you show the new feature, and otherwise you show the old. And then you're going to use some remote console for the PM to come in and say, in this case, for example, 5% of the people can see the new feature and 95 cannot. So you can control who gets to see the feature or not. We use this a lot. We use feature flags for just about everything. So we had a case example recently where we had a menu here, which was used for turning columns on and off in picture tables. And our designer at some point looked at it and said, the menu's hanging in the wrong direction and these buttons at the bottom are not valuable. So they did a redesign and we re-implemented the menu. We could have just, dumped that and dumped it out to our customers and said, hooray, but we do everything behind a feature flag. So in this case, we put the new code in, put it behind a feature flag, and then when the PM is ready, that can get turned on for our customers to see. We don't just use this for small things. Of course, we use it for major new features. So in this case, we used to have an interface where when the change was made, you could put a comment in about why that change happened. But with the feature flag, behind the feature flag, we added a new feature where you can add in approvers and then get their approval for this change. The point here is that, small features, big features, refactorings, those all live behind feature flags, allowing us to basically anything we put out, we are putting it behind one of these feature flags. With that, let's talk about some of the pain points. So if you use feature flags, and it sounds like some of you do, you end up in this situation where you're putting these conditional checks into your code, probably all over the place. And over time, you'll find this makes the code a little bit hard to read. It takes a lot of work to go and remove these things. You come back in and you have to remove the conditional, remove the old version. You have to make sure the integrity of the function is still fine. I mean, in theory, you can just, delete the lines and everything's good, but in practice, you want to sort of make sure that makes sense. You have to then go modify the tests, remove old unit tests and things like that. This also makes the code fairly hard to reason about. You'd say, well, it's a conditional. I have conditionals in my code all the time. This should be not a big deal. But these conditionals are often kind of orthogonal to the main thought of the function. And so you can end up with cases, especially if you have multiple feature flags, where it takes a lot of brain power to work through the function to figure out what's going on. We're all engineers. That's our job. Reason what's about going on with our code. But it still slows us down. And part of the promise of feature flags is to speed you up. And here's part of the whole process slowing you down. It doesn't build confidence in your code in the way you might wish it would. We definitely ran into this problem on the front end. We were doing this sort of standard process and asking ourselves, well, how do we make it easier to remove these feature flags so they're not just hanging around in our code base forever? And how do we make it easier to read the code? The first thing we did is we started to pull the flag evaluation out of our components, in this case, out of the functions and into Redux, which is to say into a data store outside of the main functions, and then essentially by dependency injection, injecting the flags, and then proceeding as we had before. Now you can compare this with what I just showed you. There's not a big difference here. However, this loosened up our thinking. We began to say, okay, well, if we don't have to do the evaluation in the function, we're just injecting the flag in, maybe we can improve this in some other way and make it easier to manage. So now I want to go on a digression. So way back in time, we wrote our programs in assembly language. This made it really efficient. You could squeeze the absolute best performance out of your computer very easily. It was highly efficient, but it wasn't super easy to maintain. You'd get a spaghetti of jumps going through your code, and when you wanted to make a modification, you had to kind of understand the whole thing to make even the smallest change. So it wasn't efficient to maintain. This gradually brought the industry into using structured programming, where you started to get formal structures like loops, if statements, while loops, functions, where we began to build up fixed patterns around how to write your code. The people who loved assembly would say, well, you're making my code so much less efficient. I don't like this at all. But in practice, it made the code easier to write. In modern terminology, you'd say we were improving the developer velocity. And because it made the code easier to reason about, it allowed you to work at a more abstract level. And so in these days, of course, almost no one writes assembly code anymore. Everyone runs with some kind of structured programming on top because it improves velocity. It may slow down the execution of your code, but it allows you to deliver features more quickly. So with that digression, let's go back to what we were talking about. So the standard process is you call some feature flag engine and then decide which feature to use. And you can, another way to think about that is an image like this. So you come into some function, you do something, you check whether to show the feature flag, you check the feature flag, decide to show the new feature or the old feature, and then do something else. We took this idea and then said, okay, well, what if we actually pull the whole check entirely out of the function? What if we did something like this, where you come in, there's a check in some body of code outside the function, and if the flag is on, you execute a new function, and otherwise you execute the old function. In this case, we call this external thing a toggler, and the toggler lives outside of the function. So rather than taking your function and embedding your check inside of it, you just duplicate the entire function, add the new code to the new one, and then when the call comes in, it goes through the toggler and then executes one of the other functions. The key insight here, the key idea is that the toggler, which is say the feature flag, lives outside of your unit of code. So in React, your unit is a component or an action or a Redux. In Java, it might be a class. You need to decide sort of what the right unit is in your particular tech stack. But the point is, get the feature flag evaluation entirely out, duplicate the code, and then have the new version and the old version live side by side. Now, why is this good? This actually makes the code easier to think about. You're not trying to commingle multiple features in one body of code. Each body is really focused on its individual goal. What's interesting here when you think about is the caller doesn't know that there's a feature flag. It's calling the toggler, which delegates to one of the others. The callees have no idea that they're part of a feature flag situation. As a result, both the caller and the callee code are much easier to reason about, much easier to think about. They're easier to test. Each one is completely separate, so you don't have your unit test trying to multiplex which version of the code to use. And actually, if you look at this example we had a moment ago, now it's really easy to introduce a feature flag in your code base. You can have a script that says, you point out this function and say, please clone that. It clones that, drops in a toggler, and now you've got a working feature flag system. Now I want to talk briefly about how this works. So if you, in this example, I'm creating one of these togglers here. In this case, you can see here in the middle here, I'm loading an old and a new version of the component I want to be, doing a feature flag around, and I'm creating a toggler. I hand it the flag name and the two versions of the function, and it hands back a new function. And that's kind of all there is to it. The actual toggler here, now, if you're not familiar with React and Redux, this is just a nightmare to read. But the essence here is this is a toggling engine I mentioned earlier. You hand it the flag, the two versions of the components. It reaches into the data store to figure out what the state of the feature flag is, and it injects that into this other function here. So this is feature on gets called. If it features on, it calls the first component, and otherwise it calls the second component. Again, let's back away from the specific implementation here. The point here is that the toggler does only two things. It reaches out to some data store to figure out what the feature flag setting is, and then when it is called, it delegates that call to one of the other two units. Again, the feature flag doesn't live in the individual functions, it lives outside. It lives between the components. As a result, the caller looks to itself that it's just using an ordinary component. That component is actually the toggler. So when you call it, it decides what to do. The new version might look like this. It's very simple. You see it just does the new stuff. This is a simple example, but I'm sure you get the point. And here's the old version. It also only is doing the old stuff. So both the old and the new and the caller are clean. They're easy to think about. They're easy to test. They're much more efficient to add and remove. And so this actually will speed up a bunch of your developer velocity and get a lot of the headaches out of your code that you might be encountering with using normal feature flags. The drawbacks are there's duplicate code, because as I'm saying, you're simply cloning, when you're incrementing your features, you're cloning some body of code. You've got both bodies sitting side by side, and they may be 90% the same. And your instinct may be, this is terrible, I've got all this duplicate code. But I think this is a false optimization, because in fact, a false optimization concern, because the fact of the matter is that this is bringing you enough developer velocity improvement to make it outweigh the fact that you've got some duplicate code. And so you kind of need to fight your instinct to sort of have a dry system and allow the duplicate versions to exist side by side for a little bit. The drawback here that is real, and I think one should be very conscious of, is this technique is really only useful when you're using feature flags to either completely add new features or to increment an old one. If you're going to have two versions of your code sit around for a long period of time, then you probably shouldn't use this feature, because in that case, if a bug happens, you have to fix it in both places, and that, I guarantee from experience, is a pain. So you want to use this judiciously. Use this when you have a high confidence that your new feature is going to cause the old one to be ripped out of your code base soon. So in summary, the key point here is move your feature flag evaluation entirely out of the logical units of your code. Use, in our case, we're using React and Redux here, use dependency injection, use aspect-oriented programming, whatever technique you use to be able to inject in the decision about which version to call. Have both units exist side by side. This makes the code easier to think about, easier to test, and makes it very easy to add or remove feature flags. And that's the summary of the talk I wanted to share. And now we should turn to questions.
Thank you, Deej. Everyone can put their questions into the chat or the Q&A. There is a few in there already. One is if your PM can disable a flag at any time, must you do a network call to decide if a flag is on or off?
I think that is going to depend on your whatever feature flag system you use, your homegrown one or a platform. In Split's case, and I think some others, the evaluation, all that logic lives in your code, and there's a periodic refresh, so you don't have to make a network call for each time you evaluate a feature flag. That's going to happen kind of automatically. So yeah, you don't have to slow down your code to be doing a feature flag evaluation for each time it happens, each time the PM changes it.
Okay, thank you. And then what was it that personally got you to start using feature flags?
So I'd been hearing about them for years. The last company I worked at had a homegrown system. I didn't get to use it much, but I know it was there. It had its strengths and weaknesses, but I recognize that this is kind of the way of the future, that it is a significant way to improve your developer velocity. So I came here and joined Split, which is a feature flagging company, and it's been really nice living in a world where just everything is being written with feature flags. I think it significantly changes how I think about writing my code, and I do think it is kind of a significant part of the future of software development. It's just another one of these tools you add, like CI/CD and version control and all the things that have been accumulating over the years to make software development faster, safer, and more efficient. So it's just the next piece of making the world better.
Yeah, no, agreed. How would we account for wanting to keep the experience consistent on a per user basis? And if we want to turn on the feature for 5% of users, can we make it be the same for 5% of the users?
Yeah, that's going to definitely depend on what framework you're using. If you're using a very naive implementation of just essentially picking a random number on each evaluation, yeah, you're not going to get a consistent thing. And that's going to be a real problem especially if you're living in or headed towards a microservice world where you've got a client and you've got a server, and the server may be multiple services. You need that flag to be evaluated the same way in each service along the way. So your platform, or if you're using a homegrown solution, that really has to find some way to provide a uniform decision no matter who's doing the flag. I don't mean to sell Split too much. Split certainly does this. I'm sure many of the other platforms do the same thing of guaranteeing that uniqueness.
Thank you. Another question is, do you use feature flags to integrate incomplete features continuously?
Oh, absolutely.
Instead of, for example, using feature branches.
Yeah, I mean, when I'm sitting on my laptop on any, I will do a feature, maybe my work for the day will be in some feature branch. That gets merged into master sort of basically as soon as that little sub thought is complete. If you, honestly, if you go to our web application and decompile the obfuscated code, you will find features in there which are incomplete and in no way ready for customer use. That is just routine in how everything is done. What we usually end up doing is we have that in there. The very first thing we do when we start a new project is create a feature flag, and then we start writing code. That's all behind the feature flag, and we go to that dashboard I mentioned earlier and turn that feature on for us internally, in our staging environment. So we can see the feature as it's growing, but no one else can. Even other development groups in the organization can't see it. We just turn it on for our own group. So absolutely, we have highly incomplete features in our code base all the time.
Great. Well, those are great questions. Hopefully we each answered those questions for you, or if you have any follow-up, please put them in. Someone also had commented that they're sprinkling their code with conditional checks. And so they're ready to use, ready to learn a better way for feature flags. I don't know if you want to comment at all about that, but
I'd love to hear if you adopt this technique at all. If you could, share how much it's using you, and if you innovate beyond that, that would be great to hear about too. My email address is here. I'd love to talk about this. I do think that, as I said, I think this feature flag stuff is a really important part of making the software development faster and cleaner. I think the stuff I presented here has definitely made our lives easier. If you use it, I'd love to hear about it. I'd love to hear about other ways to making feature flags easy to use.
Great. So your email's there. So write that down. And then also I'm going to finish up with one last question. And then if you have more, feel free to please email Deej. But they're looking for your opinion on when to bring in feature flags to new projects. For example, for a greenfield project, pre-production, would you recommend using them, or maybe wait for production?
Based on my experience of doing stuff here, again, this is the first company I've been at where just feature flags are in the blood. And at this point, I would never start a project without feature flags of some sort. It really does change how I think about writing my software, and again, makes me feel so much more confident about what I'm doing. So I'd want to get that in from day one and have that sort of the foundation of my thinking, in the same way that I wouldn't start without having a CI/CD system that's going to, blow up if my tests don't pass.